So for this video, we'll be dealing with complex fractions. So complex fractions are basically fractions with a combination of addition, subtraction, multiplication, and division. So we'll try to integrate all operations in fractions for this. So let us first recall that first, in addition and subtraction, we have this formula: a over b plus minus c over d would give us ad plus minus bc all over bd. This is also called the butterfly method. For multiplication, we have a over b times c over d would give us ac over bd. Lastly, for division, we have a over b divided by c over d would give us ad over bc, since we get the reciprocal of c over d. So we would try to use these three formulas out here. Plus, another thing that we would use is the idea of getting the LCMs of the denominator to simplify the complex fraction into a simpler one. So let's start with our first example. If we have 1 plus 2 over 3 all over 1/2 minus 1/3. For this example, like I said a while ago, the key thing that we would use here is to get the LCMs of the denominator. So for this case, the LCM of 2 and 3 is 6. So we can multiply this one by 6 over 6, which would give us 6 plus 2 times 6 would give us 12 over 3 all over 6 over 2 minus 6 over 3. Now, we know that we can write 12 over 3 as 4 times 3. Similarly, we can write this 6 as 2 times 3 and 2 times 3. So we can cancel out the common factors out here, which would leave us with 6 plus 4 all over 3 minus 2, or simply 10. Let's go on to our next example. If we have 2 minus 5 over 4 all over 4 over 3 plus 3 over 4. So for this example, again, we can apply the LCM of the denominator method. So we can multiply this one with 12 over 12. Feel free to verify that the LCM of 3 and 4 is this one. So this would give us 2 times 12 is 24 minus 5 times 12 all over 4 all over 4 times 12 all over 3 plus 3 times 12 all over 4. Again, we can write 12 in these fractions as 4 times 3, 4 times 3, and 4 times 3. So we can now cancel some common factors out here. We can cancel out the 4 here, the 3 here, and the 4 here. So these would leave us with 24 minus 5 times 3 is 15 all over 4 times 4 is 16 plus 3 times 3 is 9. And this one is actually just 9 over 25. And that is the final answer. Let's go on to our third example. If we have 1 divided by 1 minus 5 over 8 all over 2 minus 9 over 8. So for this one, we can multiply 8 over 8 out here. And by the way, we would first focus on this complex fraction here, since the other number here is just a whole number. So we'll try to eliminate first the complex fraction, since it's sore in our eyes. So this one is equal to 1 divided by 8 minus 5, since the denominator would cancel out here, all over 2 times 8 is 16 minus 9. So this one is equal to 1 divided by 3 all over 7. Now, note here that, again, when we're dealing with whole numbers, we can actually write them out as fraction. So we can write this as 1 over 1. So applying the idea in dividing fractions would give us 1 over 1 times 7 over 3, which is equal to 7 over 3, or 2 and 1. And this is the final answer. Let's go on to our fourth example. If we have 1/2 plus 1/3 plus 1 over 4 all over 3 minus 5 over 12. So for this one, we're encountering more fractions in the numerator, but we'll try to apply the similar idea as a while ago. We will multiply this one with 12 over 12. So the reason that it is 12 over 12 is because this is the LCM of 2, 3, 4, and 12. So this would give us 12 all over 2 plus 12 over 3 plus 12 over 4 all over 3 times 12 is 36 minus 5, since the 12 would cancel out here. So simplifying the numerator would give us 12 divided by 2 is 6, 12 divided by 3 is 4, 12 divided by 4 is 3, over 36 minus 5 is 31. Simplifying further would give us 13 over 31. And this is the final answer, since the numerator and denominator does not have any common factors anymore. Let's go on to our final example. If we have 1/2 plus 3 all over 2 over 5 plus 1 over 3. Now for this one, since there's no fraction in the numerator, we can actually apply the addition formula in this one, or what we call the butterfly method. So applying that in here, this would become 2 times 3 plus 5 times 1 all over 15, which is equal to 6 plus 5 all over 15, which is 11 over 15. Okay, so take note of that. So we can write this as 1/2 plus 3 over 11 over 15. Again, when we're dealing with division of fractions that involves a whole number, we can write the whole number as 3 over 1. So this one is equal to 1/2 plus 3 over 1 divided by 11 over 15. Yep. And now, with this one, applying the rule on PEMDAS, we know that we'll start with the division operation before the addition. So applying the rule out here would give us 1/2 plus 3 over 1 times 15 over 11, or this is 1/2 plus 45 over 11. Now we're just simply left with the addition rule or the butterfly method out here. So this one is equal to 1 times 11 plus 2 times 45 all over 2 times 11. And this one is simply 11 plus 90 all over 22, or 101 over 22. Or in mixed numbers, this one is equal to 4 and 13 over 22. And that is the final answer. So for these examples, we have applied a bunch of formulas revolving on addition, subtraction, multiplication, and division of fractions. And we also note that the key thing to simplify fractions is to use their LCM, or the LCM of the denominators, to simplify the complex ones into more simpler, with just a fraction with a single expression above and single expression below. So again, that is all for this video.